Hey everyone, welcome to another tutorial. This one's going to be on tables, arrays, and dictionaries, which will be very important in your game development career on Roblox, or if you're not going for a career as a hobby. And these are incredibly important. They store information, they store functions which you can access. They do so much in the scripting environment, and they are critical. So this is something important. You will want to remember this. But it's not too crazy, so hopefully you learn a bit here and you understand them to a great level. So what is a table? You can think of a table as a container, as many people do say. It stores information inside it, and you can pick out the information, you can add information, and in some cases you can call information, such as functions and such. So I'm just going to go straight to practical. Let's make a table. So table, it's pretty much just variable with curly brackets. So if we just create our local example table equals curly brackets. So that is open table and that is closing table. Now there is two types of tables. You have arrays and you have dictionaries. Now these are sorted, or actually they're defined in a way that arrays are numerically sorted or indexed, and dictionaries have string indexes. So therefore it's a hash map, it's called. I'll explain these two. So for example, I'm going to do an array first. So actually I'll do alphabet letters, that way it's easier to show the difference. So many of you may know already what an array is in other programming languages like Python. Python starts at 0, while Roblox starts at 1. So, just for people that do know what it is, for people that don't know what it is, the array has a numerically indexed table of values which start at 1 and progressively get bigger by counting up by 1. So what I mean by that is A is at index 1, B is at index 2, and C is at index 3, and so on. So that means I can say, okay, at index 1, what is the value in this example table? And I can say it's A, because that's at index 1. If I say what's index 4, what's the value of that? D, because that's at index 4. That's the fourth spot in the table. Now, if I want to access information, I have to use square brackets in the case of arrays. So I'm going to print example table first up, and then I'm going to print example table square brackets. So I'm going to try index something. So I'm going to try find the value at this index, and I want to say a number. So let's try 3. That should be C. Now let's also try something where we index a value that's not here, or we index something that's not here yet, or not existent. So we've got 5 values here, so let's do like 7 or 8. We'll do 8. So what happens if we index something at 8, even though it's not here? Let's give that a go. Let's run that, and let's see what we get in the output. So in the output, you can see we get our table. So index 1 is A, as I said before. Index 2 is B, index 3, 4, 5. So it's numerically sorted. It's going from 1 to however many items there are in the table. Script line 8. We try to get the third index of whatever's inside this array. We got C, because that is a third item in this array. Example table 8. Since there was nothing at that index, we got nil. So it returns nil because there's nothing there. So theoretically, you could say all of this, all the way to infinity, is just nil. But it doesn't take up memory, and you just assume it's nil because there's nothing there. So that is arrays. It's numerically sorted and it's numerically indexed. It goes from 1 to the amount of items in the table. To get the length of this table also, you can use table.getN. And if we have a look at that, it says returns the number of elements in the table passed. Or you can just use hashtag, which I highly recommend you use. So if I print hashtag table, that should give us 5 because there's 5 items in that table, which there is. Alright, now onto dictionaries. So as I said, this is sorted by numerical, so it starts at 1 and counts up progressively, depending on the number of items in that array. But dictionaries have string indexes, so they are indexed at the string. So if I create a local example dictionary, now let's say I want to have the key epic. I want that to have a value of 500. If I print this dictionary here, we should see something similar to what we saw before, but the index, instead of being 1, it's epic. So to access that value at index epic, which should be 500, we do print example dictionary, square brackets again, because we're trying to access the value, and we're going to put epic in quotation marks like that. So that's one way you can access it. You will need to do it this way if there's spaces in the index. So actually, let me give you an example of that. So in the case of having spaces in your strings, you will need to do the square bracket method here. Also, if you try to put instances here, you'll need to do square brackets like that. However, if you're doing just strings, you can just put the string there. And these cannot start with numbers, but they can have numbers later on. And I believe, yeah, no special characters. So you can play around with that, see how you can do it. But those are two basic forms of setting up indexes, and you can put any value. So this one here will print the table as we've seen here. And if we actually run this, they're going to be the exact same thing, even though we set it up differently. So this one's in square brackets, this one's just straight up the string, but they end up the same anyway, so it doesn't matter. So here we accessed value epic using the square brackets, but since these two are the same, we can also just do print example dictionary dot epic. And as you can see, epic noob also showed up, so we'll do that. So if we try and access epic noob, because of the spacing, it will use square brackets to do it. So if we run that, we'll get 500, 250, because epic has the value of 500, which is first, and then epic noob has a value of 250, which is next. What you can also do is attach functions, which we'll learn in modules, and that is by doing 3 different methods. You can say example dictionary dot custom index, so the string index, actually I should call it that. You can equal it to a value, so that's how you change it during runtime. You can do example dictionary dot that equals a value. You can also do the square bracket method, string index equals value, anything like that. Or actually you can do any sort of index, so like instance equals value. We'll be using this method for caching later on in our later tutorials, which is important. But that is how you set values there. So if I do that in print example dictionary, we should see string index 2. That's because we overrode the first one with the second one. And we've got table, the table ID, because instance is a table with methods attached, so .new in this case. And we can attach functions just by doing .string index equals a function, like so. And if we run that, so we can actually call the function like so, we can print the epic there. And it doesn't actually print anything because we didn't return a value from this function. So if I return epic, actually let's do legendary. So if I return a value, it will return that to the print statement and we will print legendary. What we can also do is do this a different way, which is function example dictionary dot string index like that, and it's still the same thing. Epic legendary. Now colons, I'm not going to talk about that here. I'll talk about that in module scripts and OOP programming, but that will automatically pass self through, which is to do with object-oriented programming, and I won't go into that here. But that is, you can still do it though, like that. So if I just try run that, it will still run it perfectly fine. Once you add meta methods, however, that will change, so you'll need to be careful of using that. Alright, we are back. So in this second part, what I'm going to be doing is going through the table iterators. So this is iPairs and pairs, and we'll have a look at also using a for loop, like the hashtag table way. And we're going to iterate through some tables and see what and how we get, or what we get and how we do it, and what result occurs from doing it in a certain way through these tables. But what I'm going to do first is go through an array. So we're going to loop over arrays, and we're going to see how these three different iterators work on these tables, or particular table types. So in this case, arrays and dictionaries. And we'll see how the other dictionary compares to this array, or the dictionary type compares to this array type, because they do register as different things, because arrays register as numerical indexes, dictionaries index as strings, or instances, or whatever, which is a hash map. So it's a different algorithm that's used, and yeah, here we go. So in our case of arrays, I'm just going to use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what we're going to do is we're going to loop through these, and we're going to print all values inside it. So using our standard for loop, what we have is a iPairs, which is integer pairs, or index pairs, and that iterates with the index and value. So in our case, we need to use this format, so we have our index and value for the iPairs loop on this table, which is passed through, which is here. So as you can see, it says curly bracket with number inside. That says it's going to be array. So that's an array type. It's curly brackets with number inside. And if we have a look at pairs, it says T with a type of index with a value of V for however length. So pairs and iPairs have different uses, and they perform differently. But generally my rule of thumb is iPairs for arrays, pairs for dictionaries. I've never really used anything else. So here, we're just going to print the index and value. In our case, since index 1 has a value of 1, index 2 have a value of 2, it should be 1, 1, 2, 2, 3, 3, all the way up to 10. So if we run that, 1, 1, 2, 2, 3, 3, all the way up to 10, which is correct. Also, we can use the table dot, oh, there is no reverse one. We can use table dot sort, and I'm just going to reverse these. So how table.sort works is you pass in a table, and then you have this comparer function, and you have 2 arguments. You got A and you got B. So A is the number on the left side, and B is the number on the right side. And this algorithm, which you put in here, which has to return a Boolean, determines whether or not the value shifts left, I believe. I can't remember. But basically, if this is true, that number swaps with that one. So if I print that again, so that's normal, so that's ascending order. But if I flip it like that, it should go descending order. So 1 should be 10, and 10 should be 1. Yep. So index 1 is 10, because it's descending, so highest to lowest. And index 10 should be 1, because that's the lowest. But there's another useful thing that you may use in some cases. Now we don't care about that. And many things that people, or a thing that people do not realize is, actually there's a couple things. You can use continue in this. So you can say if index is equal to 5, then continue. And you can just skip number 5. So in that case, it should do 1, 2, 3, 4, and then immediately to 6. You can use break, and that will stop the loop entirely, like we've talked about. But you can also say example arrays index equals a value. So if I do that, what it should do is, actually if I put that out here, it should print the index and value, then set the current index to 0. So if I loop over this array, we hit number 1, we print it with the index, and then we set that value to 0. Now we move on to number 2. We print 2, 2, and we set that to 0 in the actual table. So if I print example arrays here, and I print it again there, we should see all our numbers here. We got all the way up to 10, and then since I've set the value every time we iterate over it, it's now all zeros up to 10. So that is how you can change values in arrays. In dictionaries, you want to do either example dictionary square brackets at index equals whatever, or you can do, actually in this case scripting wise, you want to do it this way. So you can see like example dictionary index ... here, something like that, equals whatever. So that's one way. Well, this is actually used in profile servers. You have a profiles table here, and you'll have the player instance as the key, and then you have a profile class as the value. So then we can say get player profile. We check if there's a value associated with this player inside, or if there's a key associated with this player instance inside this profiles table. If there is, then we return the profile class, which in our case would look something as simple as that. That will check whether or not this profiles has a key which is equal to this player instance, and if it does, it will return the profile class table, otherwise it will return nil. Back on track. So we saw that we use ipairs. Actually, let me go back to that. So we saw we use ipairs to get it in numerically sorted indexes. So that means it's going to start at index 1 and count up to index however many. But we can also use pairs, and we can swap the order of some things. So for example here, I'm going to set this to... Actually, I know I can't do that. We'll just try that for now. So we'll use pairs, and we'll just see what that does also. If I go ahead and do that, it's the exact same thing. So what we know now is that arrays works with ipairs and pairs. The difference is timings and how this iterator works. Ipairs is much quicker than pairs for arrays. However, for dictionaries, let's have a look how that works for ipairs and pairs. So here I've got an example dictionary. Let's do epic equals true. I'm just going to do epic true equals false. Epic 3 equals 10101. So let's just do maybe one more. We're going to have... actually, we'll do one more, which is a function. And we'll return epic. Oh, legendary again. So here's an example dictionary. We want to try and loop through this dictionary. So let's try that. I'm not going to set any values. We're just going to try print it using ipairs. So index pairs iteration. And what we should find is nothing printed. The reason for this is because the keys are not numerical values. They are not numbers. They are strings. They're instances. And that is a part of a hash map, which does not use ipairs. What we need to use is pairs, because it will check the hash map rather than the direct table. So if we have a look now, we're getting the epic, epic 5, epic 2, epic, epic 4. They're not sorted in a specific way. So as you can see, we got epic 3 first, then we got epic 5, then we got epic 2, then we got epic, epic 4. It's not sorted. And what we can do is, if we want to change this index, let's say, actually let's get rid of it completely. So if we do print example dictionary, we should have all values. Then we'll print them one by one and delete them from the dictionary. Then we'll print the dictionary again. So we'll have epic equals true, epic, epic, epic. There's all our values. And since we wiped them from the table is now empty. Another alternative, instead of doing equals nil to every value inside the table, what you could do is just set the table to a blank table, which is a performance boost in most cases. So take that into mind. Instead of removing everything from the table, if you want to clear the table completely, just set it to a new table. Alright. So, now that we've got that, let's look at one more example, which is the back to arrays, which is using the length of the array. to loop through it using another for loop, which is the generic. So we talked about how we can access certain values at keys. So a numerical key. So I can say print example array 1, that will print 1. If I do print index 5, that will be 5 in our case. But what we can also do is say, hey, I want to loop through every single one of these. And I want to say for index equals 1. So starting at 1, not 0. 1 to the length of that array. Counting by 1. I want to do local value equals example array. Square brackets index. So I'll just go over this again. For index equals 1. So we're going to start. So we're going to have this variable called index. And it's going to start at 1. And it's going to count up to the length of this array. And we're going to do it plus equals 1. So index equals index plus 1 every time this for loop runs. And what we're going to do is create a variable here to get the value at that specific index in this array. And a quick note is this is actually slower than ipairs, I believe. I'm not completely sure. And it's much more janky. ipairs is a lot neater because you can do for index value just like that, and you don't have to have this line here. Apart from that, let's continue. So what I can do now is say print index value. The first one, number 1, should print 1 here, and it should still print 1 here. So if I run that, we'll get 1, 1, 2, 2, 3, 3. So just like what we had with ipairs and pairs in our case for this array. And what we can do next is, let's say I want to count by 2s. I can say, okay, only get me every second number. So 1, 3, 5, 7, 9. Now, this is starting at 1, but if I want to start it at 2, I can do that. I can say for index equals 2. 2, 4, 6, 8, 10. So you can play around with it like that. That might be useful if you need to say like some square size or something. I don't know how what your use case would be. But you can also do this for the ipairs loop. There's different ways though, we'll go into it maybe through different projects. But for the moment, you can take that into consideration when you're doing that. I generally don't really use these. I use ipairs and pairs almost every time, unless I need something very specific. So just keep this like in the back of your head, or just remember that you can do this style of looping. And this comma 1 here is optional. You don't actually need it, unless you're counting backwards. Actually, we should do that. Let's count backwards. So let's say, okay, we want our index, instead of starting at 1, we want to start at the length of the array, so the last one. And we want to go to index 1. So we're going to count backwards to 1. And obviously by the error, we have for loop iterates backwards. Did you forget to specify -1 as a step? So we also need to include the -1 as a step, or -1 as a step. So now if we do that, we start at 10, and we count down to 1. And what we can do is actually count down by different steps. So I can start at 10, and subtract 2 every time. And as you can see, actually, it goes from 10, it goes 8, 6, 4, 2. But because we minus 2, it went to 0, and 0 is smaller than 1, so it stopped the loop there. But if we go and set this to 0, it should also print 0. And it's nil because there's no 0 value in our array. Because the 0 value would be a string index. So that's a string index there. But if I try that now, it actually will work. Because of the hash map, how that works. But, yeah. So that's another way of looping through it. There is also table functions. So if you do table dot, you can see there's a bunch of functions here. You have table dot insert. This adds a value at the end of an array. So if I have like local example array, and I just do table dot insert example array 5, and I print example array. Actually, let's do this for I equals 1 to 5. Let's print the number, or let's add the numbers to the array. Let's add 1 to 5 to the array. So what we should see is this table now having 1, 2, 3, 4, 5. And let's say that I want to remove values now. Oh, actually I should say there's an equivalent of doing this. So instead of using table.insert, you can actually do example array hashtag example array equals I. So that's the equivalent of table.insert, but it's slower. The reason for that is you have to get the length of the table, and then you got to set the value. So you're doing 2 steps at once. And there we go. Oh, sorry, that's supposed to be number array plus 1. Because if we have 1 here, if we say number of array, it will be 1. So we're changing this value. But we want to change the value after that, which would be here. And then we want to add the I value there. So if we try that, we got 1 to 5. And yeah, that's the equivalent. I'll definitely use table.insert though. Now let's do some different experiments here. So what we have is 1, 2, 3, 4, 5 in an array. Let's do while example array, or length of example array is larger than 0, do. There's 2 ways we can remove a number. We can do example array 1 equals 0. But that means, actually if I try to run that, it's probably going to crash me, so I won't run it. Actually, I can do that, print example array. Let's try that. Step. Let's try that real quick. So you can see it's stepping infinitely, because even though we remove the first value, that doesn't mean the table's going to shift left. So if we remove this 1, it's actually going to become nil, and it will take its place. So these values won't shift over. So what we need to actually use is table.remove example array, and we're going to remove at the first position. This is used in, let's say, A-star pathfinding, because you'll have a table which you have to remove the first value from, because you're using that first value to like find where you're going to go. You don't have to worry about that though, but there we go. After 5 steps, it removed everything from the table. And we can actually watch this in action by printing the table. So here we start with all our numbers. So it removed 1 because I was first. It removed 2 because I was first in the table. Removed 3 because I was first. Removed 4 because I was first. And then we ran out of numbers and the loop broke. So there's an example of what you can do with it. And I can't recall anything else that I need to talk about. There's functions and all that. We're coming up with module scripts. Module scripts are just really simple. They're just tables that you return to scripts. It'll be quick, hopefully, if I don't make it too long. But yeah, hopefully this guide helped you out understand tables a little bit. Got your brain thinking of how you can use loops and tables together to do your systems. An important thing that you may use is, let's say, some parents get children, because that actually gives you an array of instances, and then you can loop through them and you can get everything there. So if we run that, let me actually get that code sample again. Copy code. So what this does is it will get everything under workspace. It will be put in a array, and then we can loop through that array and print everything. The equivalent of that for loop is for index object in ipairs children. So remember, children is a array, and then we can just print the index object. So there's 2 equivalents there. If we run that, we should have 1 camera, 2 baseplate, 3 terrain, 4 spawn location. Camera, terrain, baseplate, spawn location. So in our case, it's sorted by class and name or something. And then camera, same thing over. But this one's faster, I think, in our case. It's some very finicky stuff, but generally this one will be faster, especially when using tables, so use that one. the iPairs. Alright, apart from that, I think that's everything. I'll see you in the next video, which should be meta tables, and that will be definitely handy. And then League of Stats is 10. So, I'll see you then.